Welcome to Kautilya Careers. As a process of Gurukul teacher recruitment test, main paper 1, as we know that it contains 150 questions for 150 marks. That is pedagogy of concerned subject. Now let us see pedagogy of physical science. Now the earlier examinations which were conducted by the government in the name of DSC and TET examinations, they prescribed that methodology of the concerned subject. Now that was changed as the pedagogical concerns of that subject. This pedagogy or pedagogical concerns of any subject which includes what we call common topics. The topics are same to all subjects, but depends on the nature, historical development, the different methods of approaches, then we have to study all the pedagogical concerns with regard to that concerned subject. Now, as a part of this pedagogy of physical science, what are the units which were included? Now let us see the first one. This includes the nature of physics, the nature of physics and its historical development. And then what about the contribution of scientists, particularly those whose names were included in school level. So all the scientists, physicists or chemists, those who were included in science textbooks of primary, upper primary as well as high school. And then the importance of physical science in school curriculum. So these are the subunits in the first chapter, that is the nature of physical science and its historical development, contribution of scientists and the importance of physical science in school curriculum, which means why should we teach physical science? Why should the learner is supposed to learn this science? That is the importance of physical science, which was recommended by so many eminent educationists as well as educational commissions. According to their recommendations, what are the characteristic features of physical science? Why it should be included in school curriculum? These are the subunits of the first unit, that is the nature of physics and its historical development. Now let us see the second unit. It consists of particularly the values, aims and objectives of physical science. So what are the different values of physical science? Aims according to Benjamin Bloom's taxonomy of educational objectives, and its fundamental aims, what are its uses according to pedagogical concerns, the different objectives of physical science. All these things comes under this second unit, values, aims and objectives of physical science, with the suitable examples. That examples must and should be related to that of science, particularly physical science, physics and chemistry examples. So this is the second unit what he covered. Now in the third unit particularly, that is he mentioned about the child development. It is nothing but the psychology of learning and teaching. It is nothing but how can we inculcate or incorporate the ideas of physical science, the learning approaches of physical science and teaching strategy of what we call physical science. That means before taking that class, then what about the psychological principles? What are the different strategies as per the psychological principles to learn as well as to teach physical science? That's why we have to understand the child and its psychological principles. According to the child development, a physical science teacher is supposed to teach. At the same time, accordingly, the student is supposed to learn. That's why a teacher must have that awareness about the child development, which is nothing but the psychology of learning and teaching. These are the subunits in the third concept. And then in the fourth one, so the fourth topic, it is nothing but the curriculum of physical science. The curriculum of physical science and the principles on which the curriculum of physical science is constructed. So curricular principles, what are the different things which are to be taken into consideration while designing the curriculum of physical science? What we call the construction of curriculum of physical science and the different principles what we are supposed to follow to prepare the curriculum of physical science. All these things covers in the fourth unit, that is curriculum of physical science. Then followed by the fifth unit, that is different approaches and techniques of teaching physical science. So particularly the methods of instruction. There are three ways. One is methods of instruction, approaches and teaching techniques. Which one is suitable to teach physical science? What are the different approaches? What are the different teaching techniques? And what are the different methods of instruction to teach physical science with reference to a particular chapters about our universe or our earth and solar system, measurements, mechanics, dynamics, kinematics, heat, magnetism, electricity, action and reactions, structure of atom, chemical bonding, chemistry of carbon compounds, all these chapters. So particularly if you have chosen a particular concept either in physics or in chemistry, which strategy being a physical science teacher you want to adopt, whether it is approach or method or technique. So with regard to a particular topics which were mentioned in the syllabus already prescribed by the board, so we have to follow the different strategies to teach this physical science. So this is the one of the major areas in the pedagogy of physical science. So these are the subunits in the fifth unit. Then followed by the sixth unit, what we call the planning of effective instruction. So planning of effective instruction is nothing but in classroom management, how can we manage, how can we teach in order to achieve a fruitful and useful outcomes from the children. For that purpose, we have to plan effectively what we call effective instruction. For example, lesson plan, the preparation of lesson plan, unit plan, year plan and usage of audio visual aids and the different types of teaching tools or teaching aids. All this comes under the different plannings of effective instruction in the classroom, so that the ultimate goal of this planning of effective instruction is to provide more and more benefit to the children in the classroom. That's why all these things, that is teaching tools, preparation of lesson plan, unit plan, year plan, all these are worked together for acquiring more and more knowledge by the students in the class. So these are the subtopics in the 6th unit, which is followed by the 7th one. This consists of particularly the learning resources and instructional material, that is about physical science labs and teaching aids, textbooks, particularly nowadays ICT, information and communication technology in physical science. This all comes under the different types of learning resources. The material, teaching and learning material. If it is a physical science, that physical science laboratory is a mandatory. So how can you manage and organize the lab? What are the essential furniture to maintain in the laboratory? And the different what we call teaching aids, textbooks. What about the nature of the textbook, that is physical science textbook? What about its mechanical features? How that content should be presented in a systematic or organized fashion in the textbook itself? What about the importance of different project works and activity based items in the textbook? Now ICT, which has taken a new place and a new role in the entire education process. As per the recommendations and guidelines of NCERT and MHRD, now ICT plays a vital role, that is nothing but information and communication technology in physical science. How can you utilize this information and communication technology in teaching physical science to make the classroom instruction as more and more effective and more interesting? So these are the different ideas which are related to that of teaching and learning material, and this is followed by what we call 8th one, that is CCE. It is nothing but continuous comprehensive evaluation, and moreover that is the different types of devices or instructional material to assess the results in the physical science, the evaluation process, the different types of evaluation methods, how that evaluation differs from what we call measurement, the fundamental differences between measurement and evaluation. Though there are so many methods of evaluation, say diagnostic evaluation, relative evaluation, summative evaluation, but what is the importance of nowadays in the present scenario? That is CCE, continuous comprehensive evaluation. What does it mean? How do we prepare the question papers for formative assessment test and summative assessment test? As per the guidelines of education department, how many formative assessment tests are to be conducted and how many summative assessment tests are to be conducted? What is the different ultimate objectives of the CCE system? So it is nothing but the process of evaluation. These are the subtopics in the 8th unit, and which one followed by, that is 9th unit, learning disabilities. That is exceptional children and disabled children. So this is common for all children, those who are not able, what we call disabled, exceptional children, or simply what we can say children with special needs. How can you provide the quality coaching, quality teaching, and make the students to learn what we call to acquire quality course of learning. In case of these disabled, exceptional or children with special needs, what are the different strategies being a teacher which are to be adopted in the classroom to make these disabled children in a better position, to acquire more knowledge, more skills, to improve their potentialities, their innate abilities, which is based on the nature of the subject, that is physical science, which is nothing but acquiring more and more knowledge in a scientific way, in a scientific approach. So the different strategies in the implementation of the different programs which enables to learn more and more by these exceptional children and disabled children, simply the children with special needs. All these different strategies which are helpful for learning to the exceptional children are kept in this chapter, that is 9th unit, and which is followed by the last one, that is 10th unit. He mentioned about particularly the concept of physical science in everyday life and non-formal physical sciences and its education. So how it is correlated with our real life and practical life? How can we associate all the things which are happening in our practical life with this physical science? That is the usefulness of physical science in everyday life. And what about non-formal physical science education? We know that there are three processes in order to provide that education. One is formal, non-formal and informal. That means without any face-to-face interaction between the teacher and a learner, all that education which is being acquired or learned by the learner comes under the concept of non-formal. Is it possible without labs, without practicals? Is it possible to the physical science teacher to adopt this non-formal process of education to teach physical science? Yes, the eminent educationists are saying yes. How it would be? How it is possible? That matter you can study in the concept of non-formal physical science education and the daily life of a human being or an individual. How can we associate the knowledge of physical science with our activities? That is nothing but everyday life and non-formal physical science education. These are the 10 units particularly which were prescribed for main examination paper 1, which contains 150 questions for 150 marks as per the notification which was issued by the TSPSC. Now all these 10 units covers almost all pedagogical concerns of physical science. Now let us list out the first one, the nature of physics and its historical development and the contributions of the different scientists which were included in the school curriculum. And second one is the values, aims and objectives of physical science. And third one, the concept is the child development. It is nothing but the learning and teaching process of physical science. And physical science, what we call the curriculum, the planning of curriculum, the different construction principles of curriculum and so on. And next one is fifth one, the different approaches, techniques and methods of instruction to teach physical science with regard to a specific chapters which were mentioned and prescribed in the syllabus. And planning for effective instruction in physical sciences and different plans and designing learning experiences, that is included in the sixth one. And then seventh one is learning resources, that is teaching and learning material, teaching aids, teaching tools, audio visual aids, physical science laboratories, and other equipment which is required for teaching physical science. And then eighth one is measurement and evaluation, the differences between measurement and evaluation, the process of evaluation, the different methods of evaluation, and the present system, that is about CCE and its importance, and about the setting of question paper, preparation of question paper, preparation of blueprint, and the model of examination, that is formative assessment test as well as summative assessment test. And then what we call the disabled children, the learning disabilities in physical science, particularly for exceptional children in case of and disabled children, simply children with special needs. What are the different strategies to provide a better and quality education for all these disabled children? And the last chapter is the usage of physical science, how it can be associated for in everyday life. And moreover, in the same unit, last unit, about the non-formal physical science education and its process, how it is possible to provide physical science education through the concept of non-formal. So its nature and the possibilities, how can we make it in a better way to inculcate or incorporate knowledge in the physical science through the non-formal agency. These are the 10 units which were prescribed in the syllabus for main paper 1. The heading of the paper is the pedagogy of physical science. Now let us see all these chapters one by one. Now let us start with the first chapter, that is the nature of physical science. So the nature of physical science, and it's what we call some other topics, the historical development of physical science. The historical development of physical science is nothing but in the ancient period, in the medieval period, and in modern period. How that science has developed, right from the ancient period till date, that is historical development, and followed by the contributions of the different scientists, that is either physicians or chemists, and their wonderful researches and innovations which were particularly mentioned and included in school curriculum. Now when we start that concept of the nature of physical science, now in actual sense, that what does science mean? What is the meaning of science? Many philosophers, scientists, ordinary common human beings are defined in different ways according to its nature. Though all those definitions may not provide the same, but more or less all the scientists, all philosophers, all psychologists, all scientists accepted that it is nothing but knowledge, a systematic knowledge. That's why the word, that is what we call it as, whether it is natural science or physical science. The first thing is the science, the English word science. It has derived from a Latin verb, that is scire, S-C-I-R-E, which means to know. And it is also believed that it is derived from, that is Latin noun, that is scientia, which means knowledge. So there are two phrases here in the meaning of science. it is believed that it is derived from a Latin word that is scire, S-C-I-R-E, which means in English to know. And the second concept is, it is strongly believed that it is derived from a Latin noun scientia, S-C-I-E-N-T-I-A, which means what we call knowledge. And the meaning of science is also based on what we call German word. So the German word, it is nothing but Wissenschaft. This is a German word, Wissenschaft. This Wissenschaft is nothing but, the meaning in English is systematic body of knowledge. So German word Wissenschaft, which means a systematic body of knowledge. So there are three different versions, that is nothing but, one is scire, it is a Latin verb which means to know, scientia, a Latin noun which means knowledge, and it is also believed that it also based on a German word that is Wissenschaft, which means a systematic body of knowledge. So to know, knowledge, a systematic body of knowledge, whatever it is, science is always related to know, to acquire certain knowledge. In brief, we can say to know or to acquire certain knowledge. What type of knowledge? A systematic knowledge. That's why Wissenschaft means a systematic body of knowledge. Now let us see the different definitions which were stated by the different personalities on the science which are based on its nature. The first person, that is Campbell. He describes science in a beautiful fashion. As stated by Campbell, this science consists of two forms. One is, science is a body of useful and practical knowledge. This is the first form of science. And the second form is, it is a pure intellectual activity. So this is two different forms of the science as stated by Campbell. One is, the science is useful and practical knowledge. That means it makes an person, it enables an individual to get an useful and practical knowledge, and it is also shows a method how that should be obtained. That is the first form of the science. As stated by Campbell, the second form of the science is, it is nothing but purely intellectual activity. That means it is nothing but, it depends on the cognitive domain, which is related to knowledge, understanding, comprehension, analysis, synthesis, evaluation. So it improves the intellectuality of an individual. That is the nature of science. That's why it contains two forms, as well said by Campbell. One is, it is the useful product and practical knowledge. It also states that how it can be obtained. And the second form of science, as said by Campbell, is, it is purely intellectual activity. It is purely intellectual activity. Now suppose if we say in the scientist point of view, Science is a method. That means any scientist, when we consider the standpoint of any scientist, they always says that it is a method. Science is always recorded as a method by which hypothesis is tested. So it is a method. Without testing properly the hypothesis, it cannot become as a systematic body of knowledge. That's why in the standpoint of any scientist, they always consider the science is a method by which that hypothesis is what we call tested. That is the scientist's point of view, the definition or the meaning of science. Now, suppose if the same question is asked to any philosopher, that is philosopher's point of view, it is nothing but science is a way of questioning the truthfulness of knowledge. So that is the difference between scientist and philosopher. So scientist always regarding the science as a method by which hypothesis is tested, whereas philosopher's point of view, science is nothing but always it is a way of questioning why, what, how, in order to find, in order to search the truthfulness of knowledge, whether it is a fact or not. By questioning more and more, the cause and effect relation can be established. That is the concept of what we call the philosopher. That's why in philosopher's point of view, science is nothing but it is a way of questioning the truthfulness of knowledge. We have to remember the difference between the mindset of the scientist and philosopher with regard in defining the concept of science. Now, an eminent philosopher and an eminent scientist, Conant, now let us see the definition which was provided by the Conant. As stated by this eminent scientist, then there are two views through which we can be studied the science. In brief, science can be viewed in two ways. What are the two ways as stated by the Conant? That is, the first one is what he said, static view. And the second one is known as dynamic view. So there are two different views as said by Conant. One is static view and second one is dynamic view. What is static? It is nothing but rigid. Dynamic means which always undergoes so many changes. As per the concept of the static view, it occupied a central place which interconnects what we call set of principles, set of different principles, facts, laws, theories, etc. All these things. That means static, rigid. There are so many principles, many facts, many theories, many laws. All this includes, makes the science as a static. That's why there are two views. Among those two, the first one is static. And as said by Conant, the second one is dynamic view. As concerned as this dynamic view, it is nothing but it is an activity and considers that the present state of knowledge is of importance as a basis for further operations. That means the present position, the present nature of science, that should be useful for further operations. That means there should be some changes according to the needs, according to the development in technology. The present knowledge, that it should be altered or modified in order to operate what we call the further needs. That means some changes, some tremendous changes may take place. That's why dynamic view is also one of the key position it will be applied, and second one is the static view, that is standard, rigid, fixed. All the concepts, principles, theories, laws are there. So as well said by Conant, these are the two different views. One is the static view and the second one is what we called the dynamic view. Now let us see, as said by Bronowski, science is an organization of knowledge. It is nothing but a construction of knowledge. That is how it is possible. It takes out the hidden talents. It takes out the hidden potentialities in nature. So that is the concept of the science. Organization of knowledge means a systematic arrangement of knowledge. Under its process of a systematic arrangement of knowledge, nothing but organization of knowledge, that it commands more of the hidden potentials from the nature. It flourishes out. It brings out all the hidden potential from the nature. That is the nature of science. That itself is the philosophical touch of the science, as well said by Bronowski. Now one more scientist is Mr. Lemon. Science is a body of scientific information. Science is a body of scientific information, as well said by Lemon. All this information includes all these scientific concepts, whether it is a fact or law or theory or principle or hypothesis, whatever it is, everything is connected and associated with science and its facts. That's why it is nothing but, science is nothing but, it is a body of scientific information. And one more eminent person, as said by Fisher, science is a body of knowledge obtained by methods which are based upon observation, which are methods on, keyword is observation. So a body of knowledge by method. Why? Because science is nothing but it is a method. That method should be based upon the observation. Through observing, it is one of the methods to acquire the knowledge. The knowledge which is being acquired by the method which is based on the observation can be defined as a science. By observing the nature, the hidden potentials in the nature, we can acquire a lot of knowledge. That knowledge which is being acquired through observation, that itself can be defined as a method, can be defined as a science. That is the concept of the science and the definition of science which was stated by Fisher. And Here the important concept that was proposed and postulated by Joseph J. Scobb, an eminent professor as well as philosopher and as well as a scientist. Joseph J. Scobb, he himself has done a research and many innovations in the field of science. At last, he defined that science, it is not a single one. It is a multi-dimensional concept. As Joseph J. Scobb's point of view, he was the first person who explained about the structure of science. He explained about the structure of science. According to him, what is the structure of science? It is based on two parts. That means the structure of science has two parts. The first part is substantive. Substantive structure, and second one is syntactic. So these are the two different structures of science. One is substantive structure and the second one is syntactic structure. What is substantive structure and what is syntactic structure? As well said by Joseph Scobb. So this substantive structure is nothing but this substantive structure deals about the body of knowledge. That means the first one, substantive structure of science, reveals about the body of knowledge. The body of knowledge is nothing but, which includes the body of knowledge is nothing but, this itself includes all facts, concepts, theories, laws, principles, hypotheses, etc. All this comes under what we call, which makes the body of knowledge in sciences. So substantive structure gives that information about the body of knowledge. The body of knowledge of science, which includes the facts, concepts, theories, laws, principles, hypotheses, and so on. All this together comes under the substantive structure of science. And the second form or the second structure of science, as said by Joseph J. Scobb, is syntactic structure. This syntactic structure, it includes syntactic structure includes what we call the different methods and the different process and the different attitudes. So in a brief, all concepts which are related to that science covered under these two different structures, that is substantive structure and syntactic structure. Substantive structure includes body of knowledge, which includes facts, concepts, theories, laws and principles. And syntactic structure reveal that information about the different methods, different approaches, different techniques, and the process, the different process and the attitude. So methods, process, attitudes, it is nothing but which covers the syntactic nature and the structure of science. And the body of knowledge represents the substantive structure of the science. These are the two different structures, and the structure of science was beautifully explained and described by, that is, Joseph J. Stroud. Now, in this way, there are two different structures of science. The scientist, whoever is defining the science, it is nothing but an organized body of knowledge, a systematic body of knowledge, and whoever define the science is nothing but to know, to acquire, to get, to obtain the more and more knowledge. So that's why when we see all the definitions which were proposed by the different scientists, philosophers, and eminent educationists, there are three major areas. What we have to understand in brief, what does it mean? What is the meaning of science? Now let us see the meaning of science. When we coordinate all the above definition, we can come to the conclusion that is, science is nothing but science is a body of knowledge. And secondly, it is a method of inquiry and a way of investigation. Third one, it is an attitude towards life and a way of thinking. So these are the what we call, in brief, we can define the science when we coordinate and integrate all the definitions which were postulated by the different scientists, philosophers, and eminent educationists. There are three basic points in defining the science or in the meaning of science. Science is a body of knowledge, and it is a method of inquiry, a way of investigation, an attitude towards life, and a way of thinking. So this is the first one, second one, and third one. So this is the nature of the science, we can say in brief. It is a body of knowledge, it is a method of inquiry, a way of investigation, and attitude towards the life. It is nothing but a way of thinking. So this is the ultimate the meaning of what is science. That's why it is derived from the word, a Latin verb, that is scire, to know, scientia, knowledge. Even it is a German word which means nothing but it is a systematic body of knowledge. So when we associate and coordinate and integrate all these definitions, we come to the conclusion about what is science. In brief, it is nothing but a body of knowledge, a method of inquiry, a way of investigation, and an attitude towards life and a way of thinking. In this way, we can define the science in brief. Now, let us see the different, what we call the characteristics of a science. It is nothing but which reveals that information about the nature of science. What is the nature of science? It is nothing but indirectly it gives that information about the different characteristic features of science. Now let us see under the concept of nature of science. Now, what is its nature? What are the different characteristic features which will be possessed by the subject science. Let us study. The first and foremost feature as a part of the nature of science is it is a particular way of looking at nature. You see, it is the nature of science. Its fundamental characteristic feature is it always makes and enables an individual to look at nature. That's why it itself is considered as a particular way of looking at nature. That means it observes fast and gives aims as insurance against any ill effects following from the phenomena, whereas scientist considers. You see what is happening in the nature. Different people views in the different ways, according to their attitude, according to their way of thinking, according to their mindset. So many things will happen in the nature, but the different people will consider in the different ways. They think in the different ways. Suppose when anything is happened in the nature, for example, scientists consider the formation of eclipse as a natural phenomenon and enjoys the sight and investigates whether it could have any ill effects or not. But ordinary people, the common people, those who do not have that much of awareness about the science and its nature, they will treat it may be an ill effect. Eclipse sometimes results in providing ill effects. That's why they will do some certain other activities to perform, to chant mantras or offer something to God or goddess. That is the viewpoint of a common man. At the same time, all these happenings in the nature, natural occurrence, that is eclipse. The formation of this eclipse can be viewed by the scientist in a different way, which has been observed by the common person or common individual. So here that is nothing but he enjoys the sight, and moreover he will try to study about any ill effects due to causing of this solar eclipse or lunar eclipse. That's why science is a particular way of looking at nature. How it is happening, why it is happening, what are its consequences, whether it is advantageous or it remains to provide any ill effects. That's why its nature of science includes a particular way of looking at nature. That is the first characteristic feature of the science. And secondly, when we see